Okay, so this has the corrected time. So Tuesday is required to take exam 4. You definitely need an exam 4 score. If you do really well and you've done well on all the other exams, or you're satisfied with where your grade is, then you don't need to take the optional final, which will be next Friday. So the optional final, again, is a retake option for exams 1 through 4. You'll have 2 hours. You can take as many of the exams as you want to, and the higher of the grade is what is going to be used to calculate your overall grade. So the higher of the original score, or the higher with the retake option. Yes?
If you don't show up, you have to like put a submission with you saying like I will not make the final, or are we just going to not show up?
You just don't even need to show up.
Okay.
So if you don't show up, I just use a 0 for that one, and it counts your original midterm scores. So, yes. And it will be in the Engman lab for both of these, and same formats that you've kind of already seen. Any questions about either exam on Tuesday or the exams options on Friday of next week? Okay, so this will be our last class period time. And so do review your previous exams if you do plan to take the finals, and reach out to me if you have any questions or want any clarification. I'll still be holding my office hours on Tuesday and Thursdays from 11 to 12 that I'm happy to go over individual questions that you have to prepare for either exam on Tuesday or on Fridays. All right, for this exam, the topics are going to be the BJT transistors with and without motors, understanding cutoff, which is off, and then partially on, which is the active region, and then fully on, which is saturated. Second order circuit analysis, so being able to analyze a circuit, and we focused on the applications with that RLC in particular. Any questions on what the content will be for this upcoming exam? Okay. All right, so it's going to probably be most helpful to be able to use the table. So we talked about last time, how do you determine if it's series parallel? And then how do you use that table to make a solution? So we had started into this example where we determined that you find the series or parallel connection based on that final circuit. So draw that circuit based on the switches and what location they're at the final time. From there, we talked about this concept, which was a little bit newer, which is that in a branch, you can move elements in that branch around. So it doesn't matter the order, whether they're before or after the capacitor in this case. So here it was above, and then beyond or below was the same. Same current flows throughout. The differences are the difference of where the drops are happening. So we went through this example of those different drops. The same current goes through all of them. And then we moved over to finding the solution for this one, which was to find the RTH, which is based again on that final circuit. And then omega naught, and we use that to find the alpha, and then the omega naught, compare those two, and in this case we found that this one is overdamped because alpha was greater than omega naught. And so then we looked at the variables or the values for IC0, which is the initial values for IC, and VC and VC infinity. And then this one also had those roots. So remember, overdamped is where you have real roots. And so S1 and S2, we found those two values. And then we were finding the initial values. So remember, the initial value is found at time equals 0 plus. So right as the switch is closed. But we don't know, so if we had resistors only in our circuit, it would be easy to say like, well, just close the switch and analyze that circuit. But we have now these time-dependent elements, the capacitor or the inductor. And with them, we don't know it doesn't change instantaneously. So we have to find right before the switch closes at 0 minus, after it's sat there a long time, what those values are. For the capacitor, we have to use the voltage. For the inductor, we use the current. And that's when we can find the initial values, is using those values. So in this case, this was the drawn circuit for 0 minus. So in this case, it was closed first and then opened at 0. So with it closed, we found, and then the capacitor is opened because it sat there for a long time, and the inductor is a wire. So doing this, no current flows through that 0.52. And so we saw here that if there's no drop across there, this is all the same node. And so VC will be the node voltage of VX. And so finding the current in the branch times the resistance is going to give us that value of VC, which is also equal to VX. Oops. So with these being equal resistors, it was easy to see like 4 milli comes in and then it splits equally. So 2 milli goes in each branch, 2 milli times that 0.1 ohm using Ohm's law. So we get the value for VC. We're also trying to solve here for VC. So since it stays the same, that makes it easy to say that our VC of 0 minus equals VC of 0 plus equals this 0.2 milli. So that gives us our initial value for that one. With the current, so now we need to know, well, does the current change in that branch for t equals 0 plus? Because that's the other one we need to find here. That IC of 0. So that's going to be at 0 plus. So looking at that time, we know this has to act the same voltage, so 0.2 millivolts. Now the switch is open. And this acts as a current source of the IL, which was 0. Or wait, no, IL was 2 milli, sorry, 2 milli. So we use this value and we use this value to find this initial IC of 0. So what will IC of 0 be here? Correct, 2 milliamps. So that's going to be our initial value. And then our VC of 0 is the 0.2 milli. So those are our initial values. And then we just need to get that VC of infinity. So at t equals infinity, this goes back to a wire again. This is open, and this is open. And so this voltage here will be what? Will be what?
4 times 4 milliamps.
Correct. So no current in here, so all the current goes through here, 4 milliamps. So we just use Ohm's law, 4 milli times 0.1 for 0.4 milli. So now we have all of the values we want. So start with A1. So A1 is going to be 1 over C was 1 over 1.8. And then IC of 0 is the 2 milli. And then S1 and 2, let me bring those down too. So S2 is minus 7.76, and then VC0 is 0.2 milli minus 0.4 milli all over put all these there we go, over S1 minus S2, and then A2 is 1 over 1.8, at 2 milli minus S1, which is minus 4.64, 0.4 milli, that's 0.2 milli, minus 0.4 milli, minus 7.76, minus a minus 4.64, this was, sorry, 6.24. All right, so these values, A1 is 0.66 milli. And A2 is minus 0.86 milli. So VC of T, we plug into the equations of this one, 0.66 milli, E to the minus 4.64 T minus 0.86 milli, E to the minus 7.76 T, and then plus 0.4 milli. And these are all in volts. So this gives us our VC of T. And then if we want to find any other variables, here it said and asked for that IC of T. So we relate the VC to IC. So IC of T is equal to C dVC dt. So we differentiate that. And this ends up being a minus 1.7 e to the minus 4.64 t plus 3.7 e to the minus 7.76 t milliamps. All right, questions? Any questions? Yes?
Did you multiply that by C?
Yeah, so I just differentiated it and multiply it by C. And then this is the answer. So I'll leave that as an exercise for you guys to do. All right, questions? You can use Wolfram Alpha on that one too. Okay. All right. Okay. So take a minute, try to work on solving this one. And then I'll go through a solution in a minute.
Determine IC. Okay, does that simply mean it's connected and then it disconnected? Yeah. T0. It's been connected for a long time. Alright. There's that dumb crossover thing. Thank you. I need to like, what's that? I know it's rough, but what was that?
Italian breed.
I need to have my tape. No, I'm still. I mean, technically, you find alpha and stuff. I should just make the table my like wallpaper or something. That's my freaking It's like the number one best Brady made his two wallpapers. Alright, I got the table. Alright. So the series of notes. So is it a new R?
If I focus too hard on one thing, I actually just stop paying attention. Which I know is weird. Like if I'm really watching a TV show, I don't know what's going on.
Is it after it's been turned off for a long time?
If I'm like doing something else, I watch it. Yeah.
So the resistance that it sees is
Infinity.
isn't it the 12?
Does it connect after? I think it has to connect because it wouldn't be alternating. It would just be zero. Just think about it. It would be no current because there's no connection. It'll act like a current source, but it won't alternate because it's not in a closed loop.
It'll act like a current.
No, because if that's a current source, if the switch opens, there's nothing connecting the inductor to anything.
No? Oh wait, is that
I think that cross is like dot there.
Oh,
I think it's literally just zero. Maybe you connect it.
if it doesn't connect, it is zero.
Okay, so you're gonna look at it in at time the end time. So switch is open, and then you can see that L and C, you compare those two and what location they're in. In this case, they're going to be in series, so this is a series connected RLC. From there, you're going to determine the RTH, so you remove all the sources and then you look at a pathway. So you put the A to B at the location of where the inductor and the capacitor are together. So you take those two out and you put A to B. Yes?
Shouldn't there be 6 in parallel to 12 instead of 8?
Oh, yep. It's still the same answer. It's still 4, but yes, that is 6. I'm not adding well. So 4 ohms. So you see that they split, so you have 4 plus 2 in one branch and then 12 in the other branch. So those branches are in parallel to each other. So 4 ohms, and then you're going to use the equation for the series, which is RTH over 2L for the alpha, and that gives us 0.5 Nepers per second, and then omega naught is 0.625 radians per second. So what are we in with this one? What characteristic do we have? Okay. So omega naught is greater than alpha, so underdamped. So we're series and underdamped. So then we need the omega d for the damping frequency, and that is square root of omega naught squared minus alpha squared, and that is 0.375 radians per second. Then we need our variables of VC0, VC infinity, and then IC0. So to find those, again, the time right before the switch. So draw it without the switch and the inductor and capacitor and decide what they're going to do. So what is the switch doing right before it changes? So it's closed. And then what is going on with the inductor? Correct wire, and what's going on with the capacitor? Correct, open. So then we can find IC, or IL, and then VC. So what is IL here? Correct, 0. And what is VC? So not super easy to see, so let's figure that out. I can put a voltage, I'll just call it Vx. And then I'm gonna ground the bottom. So current in this branch is Vx over 12. I'm just gonna label this current going in that direction. What's that current? Correct, Vx over 6, so you would add those two together. What about this current? Correct, Vx minus 30 over 2. And then we can do a current summation of those. So Vx over 6 goes out, Vx minus 30 over 2 goes out, and Vx over 12 goes out. And then we can solve this for Vx. And that ends up being 20. So to solve that, just to back up one step, I'm just going to combine all of the variables with Vx, and then I take the 30 over 2 to the other side. And then this ends up being 30 over 2, and then I do 1 over each of these. And multiply those out, and that will be 20. So what is Vc? Correct. Vc is equal to that Vx, which will be that 20 volts that we just found. So this is my initial value. So now when I move to, or this is the right before the switch, so now when I move to switch being closed, this becomes 0, and this becomes that 20 volts. And now my switch here is open. And so Vc of 0 is 20, and Ic of 0 is what? 0, correct. So those are my initial values for that. And then at infinity, this stays open, wire open. And what is my Vc here? Correct. So that will just be 0. There's no sources in there. So now I go and plug these in. So Vc 0 is 20 minus 0 for 20. And C was 0.64. And then IC0 is 0. And alpha is 0.5. Vc 0 is 20, and Vc infinity was 0, all over 0.375. So this gives me a D2 of 80 over 3. And then Vc of t then, E, and then alpha is minus 0.5 t. And then D1 is 20 cosine 0.375 t plus the D2, which is 80 over 3 cosine 0.375 t and then plus the Vc infinity, which is 0. So I'm just going to leave that off. And these are in volts. So that is my Vc of t. And again, if I wanted to find IC of t, sorry, there you go. IC of t, I would take IC of t is c dv c dt. And it was 0.64 times the derivative of all of that. And that ends up being a minus 40 over 3 e to the minus 0.5 t sine of 0.375 t in amps. All right, any questions? Is ready for one more? Okay. Okay, so take a minute to do this one.
Alright, so it's there is. Oh, that's where I got it this time. 4/3 of the I am so confused by the nodes. It's not drawn as a node. They don't. So what? So
Okay, so what's happening here is that inductor and capacitor are already charged from voltage.
You gotta find the alpha and the omega first. Actually, it's not very clear.
I can't rotate it, so it's three connections in one line.
Okay, I got it. So it's parallel to 64. Not 4 to the 2 to the 4 to the 2. What's that? 2 to the 4.
That's why I do letters. You know that I just gotta stop my hands.
Hey, it's not working.
I keep saying that. I keep saying
And then resistance is 4. It's 4. Easy. It's just 2. Plus 2.
I'm sorry. Does the current source voltage short to
There's a shortage. Oh wait, they're equal. It's critically damped. It makes it easy. Because I calculated omega
Resistance.
it's not.
Do you use the 2 ohm resistor or not?
Yeah, I did.
Isn't it short?
At infinity, that current source Okay, so what's IL?
It can't be shorter. So it's correct. Depends what you're saying.
So how do you do this? How do you put it on? Inductor. Oh wait, I'm looking at parallel. Across the capacitor. I think it's 24 volts across the capacitor, right? It's just the voltage across 4, so 4 over 3 plus 8. So the voltage across the capacitor is 8.
Just take a KVL around.
Because the capacitor in infinity is an open circuit, so you just ignore that because that's a tangling branch. So the voltage across it. So you're just looking at the voltage across that 4 because the switch is disconnected and then it becomes connected. So after it becomes ECE infinity. No, it's 4 over 12.
Oh wait, no, it's not 10.
Yeah, it's 4 over 12.
It's 4. Make it
So now after it's connected, how do you plug in? Yeah, it does. So it's you're scared. Connect the current and then 3 amps going in, 3 amps going out. So you know. Oh, we got at infinity is 0. It's a break. It doesn't matter.
Is that an inductor?
No, at infinity, the current source is not an you can open this. And then that's a wire. So they're the same. So B1 is just 0. So what's ICO to them? We're chill. If you're not upset right now, I can't help you. It's literally cake. VC at infinity. So it's literally just 8. VC at infinity is like at all times. It's not going to obfuscate No, I'm contemplating. I think the inductor gets energized.
I think the voltage across the three amp source is the same as the voltage across the 2 drop, which will change nothing. Wait.
I don't know what to do. I think B1 is 0.
I'm just concerned that I'm
It's like always 16.
Oh, actually, he had to find that spot, which is weird to do. Basically, like your
Oh yeah, no, I didn't.
we just did.
I got one once, and then I got
I'm gonna basically be training night in a car for
All right, so for this one, you have series. Again, the same reasoning that when you look at the final circuit, you can compare L and C together. You do see that they are next to each other in the same branch, so it's series. From there, you find RTH at the infinite circuit and then remove the sources, so that becomes open for the current source. Remember, I equals 0 looks like an open, and then V equals 0 looks like a wire. So open for the current source, short for the wire, or short for the voltage source. And then your pathway from A back to B, I put the A and B, I moved that 4/3 over to the left side of the inductor. And so that becomes 4/3, and then I hit a branch, which means those two branches are in parallel. So 4/3 plus the 8 in parallel with 4. That gives me 4 ohms. And then I use alpha is RTH over 2L, and that gives me 2 nepers per second. And then omega naught is 1 over the square root of LC. That gives me 2 radians per second. So then I am critically damped. So with critically damped, I need the variables B1 and B2, and so I need to find VC and IC at 0, and then VC at infinity. So at t equals 0 minus the switch is still open. So switch is open, inductor shorted, and then the capacitor's open. So my VC and my IL here will be 0 because it's floating. And then again, I can label this as an unknown Vx, and then current in this branch, Vx over 4. Current in this branch is, yes.
Can we just do a voltage divider?
Or you could do a voltage divider, but if you don't remember the voltage divider equation, which may be, you can always go back to using Ohm's law. So finding the voltage over the resistance. So Vx minus 24 over 8. And then these are both going out. Combine your Vx variable and then divide by this. And that gives 8 volts. So the next step would be to do t equals 0 plus, which closes the switch, current source of 0, and voltage source of 8 volts. So my initial values, IC of 0 is going to equal 0, and VC of 0 is going to equal 8 volts. Any questions? Okay, and then for t equals infinity, switch is closed, inductor wire, and then the voltage VC across the capacitor's open. So now we can do the same idea as before and find current in this branch is Vx over 4. Current in this branch is still Vx minus 24 over 8. And then this is 0 because it's floating. So current going out is going to equal the current coming in, which is 3. So I bring the 24 over 8 is also 3. And then I can divide by 1 over 8 plus 1 over 4. And that gives me 10 volts. So note that Vx and Vc are the same because of the current is 0 in that. So these are 10 volts. So this was 0. Alpha was 2, I think, if I remember right, 2. So alpha is 2, VC of infinity is 10. And VC of 0 was 8. So that gives me a B1 of a -2 and B2 of 2 times 8 minus 2, 10. So -4. And then VC of t is a -2 minus 4t e to the -2t plus 10. All right, questions? Yes.
So I'm just wondering, how did you get 10 volts? I keep getting 16.
So let's see, 8 times 4.
That equation works out to 16.
Yeah, it does say 16, doesn't it? So 0, px over 4, bx minus 24, 6. Oh, sorry, that's why. I see. So this is not 0 on this side. Sorry. So that's not correct. Ah. Eraser. So you don't know what this node is here. So sorry, this one is going to be Vx minus Vy over 2. And then when you do your equations, you have Vx minus Vy over 2 plus Vx over 4 equals 3 coming in. And then on the Vy node, this current here is Vy minus 24 over 6. And then 3 goes in, and then the Vx minus Vy goes out. And then solving that gives you that Vx is 10 there. Sorry, thank you for catching that. That was my bad. All right, other questions? Okay. So because I have 2 variables, I'm going to just go take that to Wolfram Alpha and solve it there. And calculators, some of yours will set up those 2 equations and do it that way too. All right, any questions on this one? Okay. All right, next one. Okay, go ahead and start to kind of work on this. Since we're running out of time, I'm going to just kind of go through and solve it, and then I'll go back and do the explanations. So. All right, so parallel. So we're going to solve for IL of t. And then removing the current and the voltage source, we get RTH is 2, alpha is 500, omega naught is 1000. So this puts it in underdamped conditions. Solving t equals 0 minus, you get 0 current going through that 6 ohms, so all the current flows through the IL branch, so you get IL is minus 6 amps. Then you also get that the voltage is 0, so when you move to the initial time, that voltage across the inductor also is going to be 0. So VL of 0 will be 0, and IL of 0 will be a minus 6 amps. At t equals infinity, you then have current in the left branch, and then you have no current again in the 6 because it's in parallel with a short. So no current, there's no voltage, so that shorts it, so you get 0 current in that branch. So you sum up the 6 amps, IL, and then the current in that left side branch, which I wrote it going in this direction, so that's 0. We're going to put the ground on the ground. 0 minus 24 over 3. And doing a current summation gives you that IL will be 2 amps. Plugging those back into the equation, you get IL of t is equal to the e to the minus alpha, which was 500t. D1 is minus 6 minus 2, so minus 8 cosine, and then omega d ends up being 866t. And then D2, your VL of 0 is 0, so then it's alpha, which is 500, minus 6 minus 2 over the 866. And that ends up being minus 4.62. So you end up with, and then you have plus IL at infinity, which is 2. So that's a plus 2 tacked on there. All right, questions for this solution? Okay, I think I have 2 more. 1, 2. So I'm going to just include these solutions on the slides that I'll post. So if you want to use these as extra examples, to have additional examples to go through. All right, any questions before we go? All right, remember again to do your final project and study and practice for the exam on Tuesday.
How long does the video need to be? It says it should be like one that you do in class, but I just have it like
Under 15. Under 15 minutes. So quick. 15, 1 5. 1 5. So no longer than 15 minutes.